Okay, so today we're in lesson 8, day 1. You're going to need your notebook, pencil, lesson book, and we're going to be on page 68 and 69. So what we're going to do today is we're going to investigate linear and non-linear functions. Okay, so we've talked about proportional relationships, we've talked about is it a function or not, and today we're going to talk about linear or non-linear. So linear, let me write that word out for you. And in fact, I know what I'm going to do. Let's do this. In your notebooks, let's do a fun font. I want you to write this word in your notebook, okay? Write that word in your notebook. That says linear. And the reason why I want you to write that, linear. So linear means line. And we're going to talk about straight lines. So lesson 6, we asked, is it a function or not? And it had to have certain qualities to make it a function. Same thing with linear. A linear, it's going to have to be a line, but it still has to follow, is it a function or not? So we cannot have a straight vertical line. Remember, lesson 6 says, no, that's not a function. We're not doing that. But any line thereof will be linear, and that's true. Okay, so let's look here. The formula for the perimeter of a square is P equals 4 times S. The perimeter is 4 times the length of a side. Let's see what that looks like as a table. You ready? Okay, so we've looked at these tables before, haven't we? We sure have. Can you look at this table and tell me my rate of change? Oh, are you remembering lesson 7? Are you noticing that my rate of change is 4 over 1, which is 4? Good, my rate of change is 4. Do I have an initial value? Nope. Good. Okay, I was just checking. All right, now let's look at my graph. What happens if I graphed it? Look at my line. I can say line, right? It is a straight line. My rate of change is constantly moving at up 4 over 1. Up 4 over 1. Vertical change is 4. Horizontal change is 1. Rate of change, y over x, is 4 over 1. It makes a straight line. Can you think of a line that isn't straight, but that is a function? So a linear function, we've been working with linear functions, haven't we? Y equals m times x plus b, okay? Whereas if I use that formula, y equals 4x, 4 times the side, we are a linear function. Okay, what if we did area? What's different? What's different about this equation? Y equals x squared, area? What's different about it? Yeah, there's an exponent there. Why don't we investigate this table, shall we? So let's see how this works. So initial value, still the same like perimeter. But let's see. 1 squared is 1. Oh, whoops. 2 squared is 4. 3 squared is 9. 4 squared is 16, right? Okay. Oh my goodness. But look what happens to our rate of change. When we do our rate of change, is it constant? It is not constant at all. By 1, by 3, by 5, by 7. So I can't just say my rate of change is. I can't, okay? Let's look at what this graph would look like. Is that a straight line? No, it's not a straight line. It's curved, isn't it? That's because my rate of change, isn't constant. I don't have the same y over x, okay? Let's talk about what makes it different. Let's talk about what makes that different. So we know that we've talked about our linear function. right? Y equals m times x plus b. But look at this one. What throws it off? Did you say the exponent? Absolutely. Absolutely throws it off. Yeah, so we've looked at already two different things, or three different things that have actually told us if it's linear or if it's not linear. Let's go back, shall we? Let's see. What did our table tell us? It has to be constant. So if it's not constant in our table, is it linear? Correct. Okay. Our graph. That's the easiest one, right? It's just visual. Is it a straight line or it's not a straight line? So that one's easy. And I want you to think of exponents. Exponents changes the shape of my line. Now it's still a function. It is still a function as long as it follows the rules of my pen test, right? I cannot have my pen's not working, two dots on the same axis. My x cannot repeat, okay? So, yes. All right, so let's look here. We're going to look at the table and we're going to look at the graph. So look at my table. I even gave you the equation, okay? What's wrong with my equation? What does it have? Absolutely. I want you to pause the video and I want you to see the rate of change on this table. So in your books, you could pause it and go ahead and find the rate of change. Go. Okay, did you pause it? Let's see how you did. So my change of y goes, I'm minusing. Let me back up. Okay. Goes 5, and then that's 3, and then that's 1, and then that's plus 1, and then that's plus 3, and then that's, we're all over the place, right? But always make sure you check this side, because if this side is equal, but these are all of 1, 1, 1, 1, 1, 1. The rate of change is all over the place. So this is definitely nonlinear. And then look what happens when we graph it. It's definitely a curve, right? There's no straight line. There is no straight line. So let's reflect about what we've just talked about just now. Can you give an example of an equation that is a linear function? And then can you explain why it is linear? Pause my video and give me an example of an equation that is linear and explain why it's linear. Let's see how you did. Okay, did you give me anything that was written like this, where my m was a number of any kind? Because that would definitely be linear. Why? Because my rate of change is right there. Did you give me an equation that was written like this, but you gave me a number here and you gave me a number here? Yeah? Good. Because that's linear. That is a linear function. The only thing I would not accept is if you gave me anything with an exponent. So if you have exponents anywhere on your page, why is that a non-linear function? Because that exponent is going to change exponentially. And I'm using that word because that's what it does. It changes it faster, super fast, exponentially. So that's what changes my curve. It gives me a curve in my line instead of my pretty straight line, because my rate of change is constantly changing faster. So, all right, guys. Okay, so let's try one more thing. Okay, so let's see if you can come up with the initial value and the rate of change and tell me if it's linear or non-linear. So pause my video and try to do this in your lesson book, and then we'll compare answers. Okay, pause. 3, 2, 1. Okay, let's see how you did. So with this guy, we're going to start in this column. He's definitely linear. Okay, because I have the equation form and there's no exponents and we're good to go. Okay, let's look at this guy. Oh my goodness, there's an exponent. Well, do I have an initial value? Nope, we're not adding or subtracting anything. My rate of change is going to vary, so he is definitely nonlinear. Okay, let's look at the next one. Do I have an initial value? Good, I sure do. Guess what else I have? I have an exponent. So he's going to vary, and he's nonlinear. Okay, let's look at this one. Do I have an initial value? Sure do. And then what is my rate of change? Ooh, my rate of change is 2, and it fits in the y equals mx plus b. We are definitely linear. Finally, my last one. Is there initial value? No, there is not. And I have an exponent. It doesn't matter what my exponent is. It's an exponent. So it is definitely going to vary, and it is going to be nonlinear. Okay, so what I want y'all doing, guys, is IXL Z17. And it's very easy just being able to recognize the graph and equations, at least, if it's linear or nonlinear, and getting some practice in, okay? All right, guys, I miss y'all bunches, and I hope to see y'all real soon. So please practice, please do your work, and love you, miss you much. Bye.